I'll start back with the launch then. So we either launch from Wallops, Virginia, at the Wallops Flight Facility, or Kennedy Space Center in Florida. And this time we're going up on SpaceX, so we'll launch from Kennedy. The launches are timed so that it about when the space station is rising over the western horizon, and so that they can match orbits. The Falcon will throw the Dragon up through the atmosphere into orbit, get to orbital velocity 17,500 miles an hour, and then over the next several orbits, the next couple of days, that orbit will increase until it's sitting right underneath the space station, parked. And when they get the go-ahead to enter the box, the safety box that's around the station, the no-fly zone, they'll slowly drift the Dragon in closer to where it can be reached by the robotic arm. One of the astronauts on board the station will be flying the robotic arm and grapple the spacecraft and berth it. It's not docking, because docking is something that it comes in on, the spacecraft either piloted or automated, comes in on its own. So it's going to be berthed at one of the pressurized mating adapters, the PMAs, and then when they get hard dock, when it's locked in, they get a good pressure seal, they've confirmed all that, then they'll open the hatches, and the astronauts will start to offload the cargo and supplies, one of which will be our ExoLab. And then that will get installed in the U.S. National Laboratory in the Destiny module, in one of the express racks that are big lockers that the ExoLab will sit on a card and slide in, where it'll receive power, and then the telemetry will be communicated through that. And that's what will allow us to observe our experiment on orbit. We'll be able to get photographs every half hour, and we get environmental data every several minutes. And that's all analogous to what your ExoLabs will be transmitting as well. So when you go to the platform, the experiment platform, you'll see those two experiments side by side. So that's kind of in a nutshell how we get to space. So this lesson then, if you scroll down, Kristen, I can walk you through it. This is always the first thing I assign, and there are videos that you can share with your students, easy enough to search on YouTube. One of the best I like is Sonny Williams did a whole series of tours of all the space station, and so it really gives you a sense of what goes on in there. So right there, current research. So this is the science that's going up. This needs to be updated. This is for 22. So I'll have to update this for 23. But the current science that's going up will be on there, and the link, I'll have a new video because that hasn't been released yet. So keep scrolling down. Some questions to get, why do students, why do they think that would be advantageous, and just getting a little bit of interaction with them. And also, I think I don't have that on the high school one. I'll have to add that to high school. There's also Google Earth has this in Street View. You can tour the space station, so get a little bit of a virtual reality. And if you have VR equipment, there are a couple of really good ISS programs that friend of mine has it, and it really, I know I can find my way around in that thing because I know the proximity of modules to each other, and when you go to the cupola and look down at Earth, it's like it's there. And you almost feel like you're gonna fall into it. It's pretty cool.
Hey, Michael.
So that's yeah.
Can I add something?
Yeah.
Kristen, when you're looking at these lessons, now the entire lesson is broken up into multiple sections, and it is exactly the same as the table of content on the upper left-hand side.
So you scroll all the way back up to the top.
Area. Right. So, for example, like these particular lessons, some sections are actually like essay questions, and some of them are multiple choice. So now the student, when they log on to their own account, there's nothing for them to do until you assign them a lesson.
Right.
Yeah, when they log on, on the dashboard, it will be blank if they don't have an assignment. So go ahead and click on assignment. Assign class. Now, since you only have one class, you just assign to that, right? You can change the start date and the end date. And then all you have to do is click on assign class.
Sounds good.
And so then when your students log on their homepage, they'll see the tile for that lesson. That's on their home screen for when they log on to classroom.magnitude.io.
Okay.
Right. All they have to do is click on that tile, and they will be doing one section at a time.
Okay. Is it like a...
Right, so they won't, yeah, that's a good, so the student won't see the entire lesson. They'll just see the first section, and then there is a button that advances to the next section, and the next section. So you can really pace them through it if you're, which is great if you're doing it as a whole class. And it also slows them down to make sure they're not just clicking through.
Right.
Okay.
And then if you click your home page, your home button, yep, right there, dashboard.
Dashboard, yeah.
You won't see anything now because you don't have any lessons assigned, but they're underneath where it says welcome to the Magnitude platform. Once you've got your class running and you've assigned lessons, you'll be able to actually see the progress, and you can very quickly see who's on target in terms of getting lessons completed. If somebody hasn't done anything, or if whatever, and you look at each individual lesson that way.
Okay, so then they are interactive. So then
Yes.
they'll be live. It's not that they need to go to Google Docs and type the responses to those questions. They'll be able to type directly into the assignment.
They can put their questions directly into the essays, and if you click that sidebar again, see where it says notes. You can see your students' notes on that. So, and because they have a little notebook function within there, so where they can, little notepad where they can be taking notes. And you can, like if you're doing this as a class, you can ask kids to, in that individual think time, put your ideas in, before we talk about this as a group, put your ideas into the notes and submit that, and then you'll be able to capture things like that. I like to also use it when they're on the experiment platform, and they're making observations, they're anecdotal observations. I have them log in there so I can see the development, who's noticing what, and just see how that's developing as we go through the year. The
Right.
essays will show up. That's within. I'm trying to remember where that shows up, Tony. Do you remember?
Well, it will show up in the menu bar as well as soon as they have.
Once they're there, okay. Once somebody submitted something.
Right. So
Yeah.
You as a teacher, you can click on that and you can go through all the different essay answers, and also you can comment on it.
Okay. Okay.
Yeah.
Now, if I'm a student and I want to do some investigation or come up with inquiry-based questions or whatnot, then do they have a sidebar like this that says notes as well, where they can go in? Because Shannon and I teach two different classes. So we have the Ag Plant and Soil Science, which is the introductory it's our Ag Bio. And then we have the Advanced Interdisciplinary Science, which is our research-based course, which we run agri-science research projects through. And so I could see those guys coming in here and putting in their notes. We have another system that's called the AEs, where they journal what's going on in their project. But I could see them, if they have this notes section, they could copy and paste into both databases and complete their research for their assignment. And then we can monitor that completion of the research or their notes that are going on each week, and that they're progressing through their research, and they're not waiting until December 15th and it's due, the project is due December 17th and all their research.
Exactly.
Well, in that case, I would recommend creating a separate class for that, right? So this way you can now, the lessons. There is another really great function, is that you can you can clone a lesson. Once you clone the lesson, you can modify it. and you can modify in a way that the way you work with the other teacher, right?
So, but in answer to my question, then there is a notes on the little sidebar for the students.
Yes. Well, that's how they access the notes they've already taken. To take notes, it would be within a lesson. So if you click back, go to the lesson library, and let's open up a lesson.
So that's why, Tony, you were suggesting cloning the lesson and then adding a little note.
Exactly. Exactly.
Right. So all their notes will be tied to.
Just click open any lesson.
Will be associated with that lesson.
So you'll notice on the right side of your screen, underneath the magnitude icon, there's a little black notes button. And if you click that, there you go. Now you've got a notepad. And then, so then you just need to have them save their note each before they don't, if you know, each entry, and then when they're in their My Notes, they can export that as a PDF that they could actually then save or print or email to you. You know, however you wanted to handle that. But you'll always be able to go back and look at it by looking at the student notes. And you obviously can make notes for yourself in here. So as you're going through and looking at lessons, this is a good place to jot down ideas or anything you want to do with it.
Right.
So let's say so if you want to clone one of these lessons, you see the purple underneath the sign class clone. You can make an exact duplicate of this lesson, and you'd want to probably rename it somehow so you knew exactly what
Go
it
ahead
was.
And give it a name. Just go ahead and give it a new name. Yep, rename it.
So click where the name, yeah, there you go. Right. You can edit that.
Okay, now click on the menu bar. Go to My Lessons.
I don't know if it cloned. I didn't see the success button come up.
Oh, she did not click on the clone. Okay.
Yeah, go back.
Refresh.
So now I go back to the lesson again and try to clone again.
Yeah.
Yeah.
Clone.
There we go.
All right.
So now it's already changed it. So at this point, you could just start editing. And you see, because you see the little pencil icon for each section. Or you can add additional sections. If you like this, but there's something extra that you want to add in for your students, then you can do that.
Cool.
But then Tony wanted to show you where this resides now so you can easily get to it.
Right. So click on the menu bar on the left.
Which part of the menu?
The black sidebar. All the way, there you go.
I'm sorry. I lost you.
The black sidebar all the way to the left. Yeah.
Right. And click on My Lessons.
Oh, cool.
Right.
Okay, I accidentally did it. And I can
So this way, you have a good collection of all the lessons that you are working on or that you are modifying. And once you have the modification fully done, you can assign this lesson to your class.
Okay. And if I want to delete my clone, how do I delete my clone?
If you want to delete it, go open the lesson. Lesson settings. And the purple, yeah, click that, and then down at the bottom, delete.
Love it.
Got it.
Oh, it's gone. Good.
Michael, did we miss anything?
Not that I can think of.
What should be our timetable for maybe a week prior to launch that we should be ready to go with all of our systems, kids and their cubes ready to go?
Yeah, let's go to the lesson library so I can show you where those protocols and everything are.
Okay.
So in the week prior, you'll want to introduce your students to the idea of doing science in space, the objectives of this research being achieving root nodulation on orbit, and then experiment design.
1 second, Michael, let me find it first. It's the first one, science introduction.
So that's the one we did, right? So then you'll introduce them to the space station and doing science on orbit and why we do that. And you'll want to go over the basic objective of our research, which is to achieve root nodulation in microgravity. So you might want to do a little bit of just legume and rhizobial symbiosis. You don't have to get very far into it at that point. You can dig deeper into that after the mission, really. But enough for that to give them a context of what they're looking for. Just do some KWL stuff around that would be my recommendation. Okay, let's scroll down. I can't remember what the order is and how things appear here, but let me see what the keep going. Experimental design setup. I think that's the one you want to do next. Yeah, I'm not sure. There should be something called ExoLab setup. So go back to the lesson library. This is good for me to see this. We're just trying to get everything ready for our PDs next week. Make sure everything's on the platform. There it is. That's the one I was looking for. So you'll want to go through this because your students are going to be actually setting everything up. So ExoLab setup. That is definitely one that, and you will want to have them read that. Let's go ahead and open that lesson and go through that one.
Is there a high school ExoLab setup or?
I thought I saw the high school one there on all the high school stuff should be on the far right.
Right.
Up.
There you go.
Yeah, there it is. One more up.
No, that's it.
One more row up.
This guy. Okay, got it.
No, that's not either it. I'm sorry.
Experimental design setup?
Scroll down one row. No, it's called ExoLab setup.
Yeah, I saw it earlier.
One more row.
Down. Yeah.
There. This is upper elementary. I don't see the high school one, so we need to open the upper elementary one, and it'll. I will make sure. I'm going to make a note that the high school one's not there and get that on there. And there will also be a PD next week going through all of this. So let's open the upper elementary one.
Can you click on it?
Did you want me to click it?
Yeah, open up that lesson, please. So this will go through the whole experiment, the objectives of the science. There's an outline for the teacher, the standards alignment, and then the protocols for setting it up. So for the students, for the younger students, we don't have them set up the tubes by themselves, but you'll likely want to have them go through the process of preparing their media and pouring their tubes and all that. And you'll want to give yourself a couple of days for that process because you'll need to make media. First, you have to sterilize everything. You'll have to, and all these steps are in the protocols. I think if you scroll down further, there's a document that goes through all the steps. And it'll definitely be in the high school one. The students will be able to access everything. Yeah, their teachers and curious students can read the full protocols here. I don't know if that opens up. I got to make sure. So you'll get everything prepared, pour your tubes, plant your seeds, put them in the ExoLab, get all your labs started up. That you'll want to do. I would say you'll want to be familiar with all this, and you could make your tubes if you have a refrigerator. You could make your tubes the week prior to launch, but don't plant. Because as soon as you put the seeds on the media, they're going to germinate. And then what I would recommend, we use it. We add Let me hold up one of my tubes here so you can see. We put a little strip of biostrate felt, and if you can see that the seeds are in, to prevent them from germinating until we inject half a milliliter of water on orbit to prime germination. But you don't need to do that on the ground. Okay, so once after launch, it takes a couple of days before we're docked and powered up, so that either later that week or even the following week, so that September, what would that be? This is assuming we go on time. September 6th, that week would be a good week to actually power up your labs, because what happens is it'll give our system plenty of time to cache the orbital data and photographs, so that when they log on the first time, it won't be a blank screen that says data soon or something like, I can't remember what the message is that it says, or no data at this time, stay tuned, or come back, or it'll plenty of time for everything to sync. And that'll give so the whole point of this being, you don't have to put pressure on yourself to have this all ready to go on launch day. Okay?
So about
you could wait 6 months if you wanted. You could do as much preloading of the science as you want. You could get into this as deeply in terms of like you could have your students go, the way you have it set up, and it might be a good way for you to go is actually go through that whole experimental design process prior to actually starting, or maybe start one lab that they can log into and monitor as the control experiment. And then they're envisioning, because it sounds like, because you do guided inquiry here, so maybe they'll get primed from those first few observations of, oh, well, what if this, what if that? And then each lab group can create their own analog of the analog to test a particular variable, and go at it that way. So maybe they don't even power up their units until sometime later in the process. It's really that's something y'all you kind of have to figure out what makes sense for your situation. Now, you're going to be a very actively engaged school, so I will offer my time as I can as well. If you want to brainstorm something around curriculum, I'm happy to do that with you. And you can just contact, I'm just Wilkinson at Magnitude.io, and we can set something up and brainstorm that. And if there's a particular lesson that you want to create, I can help you design that, or work with you to create that lesson so that it supports exactly what your objectives are. And I think that's one of our biggest strengths of the platform is it's not prescriptive, and you can easily modify it and use it in whatever way makes the most sense for your situation, because not everybody's classroom is the same.
Okay.
So
I'm thinking that they all needed to do this first round together with the launch, but they don't.
no, you would not have, if that pressure seems unrealistic, if that feels like it would be really pressed, I would not do that. I would set up one lab, maybe one lab for, I don't know if they're in different sections or what, but maybe set up one lab for each of your classes that they're going to be, that they could follow in real time with the mission. So they'd log onto the platform, see the experiment, and you can monitor it, and you can still assign lessons and everything through that. But then for their individual labs, maybe wait until they have a sense of what this actually is and what it does. But that's entirely up to you. Maybe it makes sense for the flow of your curriculum to introduce this tool right away and build it. So you may want to take some time and chat about that amongst yourselves and decide what makes the most sense.
Okay, so then a germination date as far as adding, moisture. Do we add moisture?
You won't have to add any moisture. We do, because we try to keep our seeds dry for launch, so they don't we want them to germinate once they're in microgravity, not ground germinate already, because we're dark for several days, so we're not powered going uphill. So we're 3 to 5 days in the dark. So we try to hold our germination for that 3 to 5 days. Now you can analog that, and we do have classrooms that do that. They put the seeds on the felt and put them in the dark for the 5 days, and then inject a half milliliter of water onto the felt to wet it and to germinate the seeds, and then go with it. But I think that's especially your first time through, I don't find any great benefit in your going through that.
Okay. So about.
But the point to be, to remind them, if we might see extreme, we might see they've germinated already on flight before it even powers up, and we've got etiolation. The hypocotyl is really long, which is not a good thing. So we hope that doesn't happen this time. We're trying to mitigate that.
Okay, so about the 6th of September, we're waiting till it gets up there. We wait till they get it all offloaded, powered in,
Yep.
and good to go. And then you'll notice
Right.
we'll have our kits pretty much ready to go, but also not plugged in until you say go. And then.
Well, you can decide when your go is, but what I'm telling you is that week of the 6th, that's a good time to start. Assuming we launch on time.
Okay.
Every day that we slip, you'll want to advance your timeline accordingly. And in the industry, the nickname for SpaceX is SlipX or ScrubX. So that's how likely it is that it will not launch on time. And I try to say that enough so that we actually do get a SpaceX launch on time.
Okay, well, it sounds like, so now at this point, we're just going to then wait on Caesar to let us know once everything's been, the Wi-Fi issue's been cleared up. And then we put it back in its little ExoLab cube, put the cover slip on, and kind of just leave them there housed and ready to go until we go through the protocols of the gel and seed, and then about the 6th.
Yeah. And I don't know what your bio facilities are. If you have a hood that you can really do this aseptically, no. Okay. Neither do I. I do this. The students do this on their tables. They wipe them down with alcohol, and glove up. I'm sorry. Say that again, please, Kristen.
I'm just teasing. I said we have a closet and we could put a fan in there, but that's.
Yeah, and that's this is clean science, not totally. You just can't create that big of a sterile field. For the ethanol, I recommend buy a bottle of Everclear. It's the cheapest way to get 95% ethanol, because you're like $20 for a liter instead of $40 for a liter at NASCO or Flynn or whoever. And it's the same thing. It's just not maybe quite as pure. But that's you just need to kill whatever surface bacteria is on the seeds. And out here in the Northeast, we've got all kinds of molds and mildews, so we try to prevent that from blooming on the surface of the seeds when they get wet.
So have you guys done, and just curious, any experiments with like apron or thyrum or anything like that, like coated seeds?
We've tested some of the rhizobial coated seeds. We haven't done anything with any of the antibiotics, so those are some great ideas that you could test. We inoculate the media with the rhizobia powder, and then top dress it just with a little puff of the powder to put a little more on the surface of the slant. I also I don't know if you can see it here. I do a little shake and bake coating of my seeds with the rhizobia. So I've got some clover seeds in here and the rhizobial powder, and I just agitate them to get a little adherence of the dusting in there before I plant them, just for a little extra kick. So it just that's a great place because this is novel science. Nobody's done this before. There have been legumes that have been grown on orbit. There's been bacterial research done on orbit, but never trying to get root nodulation because there's a minimum time that we need. And historically, a lot of the experiments just have not run that long. They've only run for a couple of weeks, and it's hard to get to your first trefoil in 2 weeks. And just all of the issues around launch stress and environmental stress. What's the impact of carbon dioxide? Carbon dioxide levels nominal on station is over 1,000, and you could very likely see 3,000 or 4,000 parts per million on orbit. So we've seen higher because the maximum that they have right now is 7,000 because that's submarine. But the astronauts are up there for so much longer, and there is no fresh air recirc. So they found that that's way too high, and it does cause behavioral and cognitive issues for the astronauts on board. So, I'm just thinking in terms of your Earth science, that's an issue that probably that you get into is carbon dioxide enrichment in the environment. Well, the conventional wisdom would be, oh, well, the plants will just chew it all up. And I'll leave that there for you to investigate and see what happens when plants are growing in an enriched carbon dioxide environment. And you can actually take those little CO2 canisters and create, put your ExoLab in some kind of sealed container and push your CO2 levels up over what your classroom ambient will get. Probably by the end of the day, if you're closed up and you don't have great air circulation in your room, you'll probably be pushing 1,200 parts per million in your classroom by the end of the day. But then that'll drop back down to near 400 overnight. So you'll have it cycling. But I've taken a container and sealed it, and actually we'll inject CO2 into it and keep the levels up around 2,000-3,000 parts per million just to see what happens, how the plants respond to it. So that's a nice tie with, because I'm sure with your earth science, you're going to get into nutrient cycling and carbon cycling and nitrogen cycling. This all really complements all that really well, deals directly to issues of climate change. How are our agricultural crops going to react to an enriched CO2 environment? Warmer ambient temperatures, drier, so you can do all this work controlled. You can get into soil recipes instead of using our agar media. You can have them create soil recipes to analog what it might be like to deal with depleted soils on Earth, or to turn regolith on the moon or Mars or an asteroid into viable growth media. So that's some of the the big science that I think y'all can handle. And again, I'm happy to brainstorm any of that with you if you find that useful.
There's one other thing I wanted to show you on the platform.
Okay.
Now, how do you get your experiment started? Right. Okay. Your ExoLab.
Oh, right. That's probably useful.
Yeah. You have the tubes ready, and how do you get your experiment started on the platform? So this is what you do. Go to classes. Click on your class. Now you see a start experiment, the button.
Should I?
Yep, go ahead and click on it. Now, the first thing you need to do is select the lab that you want to pair to. Click on that. Now, right now, you don't see the ExoLab-9 ISS.
Why don't you make it New York? Do the New York IGS, because that's running right now. That's right over here.
Right. So when we are ready to get started, you will see that selection.
So the top one after launch will be ISS ExoLab-8 or something, or ExoLab-9, something like that.
Right, ExoLab-9 ISS. Yes.
Okay.
And then you can give it a name. You can give it your special name right here.
Yeah. So why don't you call it your class name pre-flight. Okay, and then use today as the start date. You can make it private. It's better to keep it open.
Right. Okay.
Now with the lab, we talked about petri dishes, or did we? I don't remember. There's a variety of things that you can put in it. You can use test tubes or petri dishes, both the 10 millimeter and the 10 centimeter or 6 centimeter plates. 3 centimeter plates, the little ones. And you can also bifurcate the lab, so you can have 2 different light settings. Right now, just go single. It says single plate, but you can do that with test tubes as well. By default, we use magenta light, 10 for the intensity and the photo period of 16 hours. That's what. Now we're just verifying the light recipe of what's going to be on orbit, so we might ask you to put it in white to have a pure analog of the flight experiment. But you see those are sliders for the intensity of light. For the color of light, you can select individual spectral. So red, blue, green, magenta, which is what most growth light is, or full spectrum light. Intensity, so you can have either 100% or clear down to 0. And then photo period, how long the lights are on in a 24-hour period. On station, we run 16 hours, but you could set that at whatever, if students have an experiment around that. And you chose single plate. Right now, this would make both test tubes have exactly the same lighting conditions. If you did dual tube, then you could set one of them as your control and one of them do some kind of experiment with the lighting conditions.
I like that.
Okay, so you could still see where it says use dual config. You could click that and it'll give you the left and right settings.
And so you would set this to clear.
So so you could put maybe one white light and one magenta light and see if there's a difference.
Oh, nice. There you go, agri-science project, Shanna.
And then go ahead and click save experiment, because you can always end it and just ignore it. So here's the platform. Right now there's nothing there to see because you just started it. But this is when you click that experiment button, this is what you and your students will see once the experiment is running. So that on the left is your ExoLab. On the right is the ground station, if you paired to a ground station in pre-flight, or the ISS. And you'll have the environmental data, the local time, how many days after planting. And then right here you can see, now it won't let you go past wherever you are in your experiment. So maybe if you unshare your screen, I can share my screen instead and give you a little view of that.
So on that screen, you are able to see every single classroom that is running the same experiment, wherever they are. Yeah, you might find a school in Romania, South Africa, New York, Kentucky. So
now these websites, like the dates are like April and things like that. Now are these still? How long do you let these experiments? It looks like it started on, here's one, April 25th, 2020. You just leave it going? How long?
Some of them, they have forgotten to end their experiment. That's why they are showing up still.
But I can see.
So I would end. We will notify you during the flight experiment when we're powering down and being stowed for return, and you can make it the same number of days. I think our mission nominal is 30 days for this flight. Mm-hmm. So after and this trial, it is about, can we achieve nodulation in 30 days? Is that even possible? So that's that probably is. I need to put that in the. So 30 days after planting would be experiment termination, if you want to stay matched up with what we're doing on station. All right, so here, let me share the screen,
and we
so you can see
that. So your experiment is insane.
Right. So and with the way you got things set up, then after you've done that initial 30-day flight experiment, then you can really get into that inquiry. Well, what if this happened, or what if that happened, or what, you can play around. What if we had a longer time? Would we get nodulation? Might that have happened? Mm-hmm. So this is what mine looks like with my classes. If I click, I've got one class running for the summer. Then my class list is there, so all the students. But you'll go to ExoLab, and I'm going to choose my pre-flight experiment. And so this is at day 45. So here's what you would see once you're in the experiment, or if you've gotten toward the end of it. This is the Wayback Machine. So I can go all the way back to DAP 17, and I can find exactly when certain milestones happened. When did the first trefoil appear? When did the singlet appear? When did germinate? How long did it take for germination? I think I ran these these ran in the dark before germination.
This is our time travel machine.
Right.
You can go back in time.
And then the compare, what you were looking at before, when I click compare, so now I can see all the other ground trials that were running, and I don't want them to be at day 45 because I don't know that anybody else is that far along. Let's make it day 12. So now I can go back in and I can compare all the other experiments at that same time. Okay, she didn't even set up. Who's got, right? And see what's happening with them. And do we still have the ability to message, Tony?
Not yet. Not yet.
Okay.
Yes.
Okay. So, and you can filter by, you could look at by country, but there's, so this is going to show you all of the labs that are running that experiment at that point in time. So day 12 running paired to this ground station.
On day 12.
On day 12.
Yes.
So once you're on the, on the flight experiment, you can pull up everybody who's running ExoLab-9 with you, and really make comparisons. What do you notice happening in other people's labs? And can you tell from their setup what's going on? You can see what their lighting recipes are, because you can see the configuration down at the bottom of that gray. I guess I didn't show you that. Let me put that back up. So you don't have to guess what they did. You can actually see how they set it up. So I can open the configuration and I can see, okay, this person's running luminosities of 10, photoperiods of 16 hours, white light.
Mm-hmm.
And what was I running over here? I was running 10 and white. And the other one's off, looks like. And notice I didn't germinate. That could be why. This person's running magenta, I think. So
all this information can be really useful if you really wanted to run experiment and asking everyone to do slightly different things, right?
Fun. I mean, let's get started. So, should we contact you after we get the internet up and going, or just send you an email, let you know where Wi-Fi is a go? Kids
Yes.
are a go?
I'm happy to help with the Wi-Fi. We just got an email from Cesar, and looks like he just connected us with the right person. So yeah, as soon as that's ready, we can hop back on a Zoom call and get you connected.
Okay. And then if Shannon...
And you might want to set up I would recommend that you set up one lab running the ground station so that you've gone through the process of making up your tubes and all of that, so you can see where the challenges you'll have with your students and just some of the things that you may want to work into how you integrate this.
So we can we'll set up a time, maybe Shannon, where we can do that next week together and
Yeah.
do with it.
Yeah, that's a good idea. Kind of like a trial run.
Okay. So we'll go back then and we'll do the ExoLab setup lesson maybe together, and then
And your students come when, or you already have them?
Monday.
Monday, okay.
Wait, Monday this week or next week?
Monday next week.
Oh, okay. Yeah.
A lot of work to do and a little bit of time, but we got it. Done it before, we'll do it again.
So I heard you mention that there's professional development for all teachers next week. I don't see that in my email. Did you have it maybe, Christy, or was this in place of that?
Well, you can do both. Certainly, you can come on to all the different sections. Now, if you go to Magnitude.io,
Okay.
hover your cursor over ExoLab, you will see professional development schedule. You see it?
I just got to the web. Oh, and then you can do
The regular website.
Yeah, gotcha. Oh, already see it. Yes, got it.
Okay.
So some of the sessions will go into more detail around the science. They'll go more detail around the lessons for high school specifically, and some of the authors will be there for those lessons. So it's a good opportunity to see what there is and ask questions of them. And then the setup, the platform and those you may not may not need now since we did those 2 sessions.
Right.
Wonderful. Thank you very much.
All right.
We're excited.
Yeah. Yeah, if any one of you are on Facebook, look us up. Well, Kristen and I are connected already. Yeah, we have to get you in the ExoLab teacher group. Yeah, we often share different ideas and new information and stuff right on there too.
I have one more question. This little puppy that's still, powered up here, should I leave it plugged in and just wait? Or
what does the Wi-Fi saying right now?
I think it still says NA.
Okay, you can unplug it.
Okay.
Yeah.
You can take it home. You can take it home and connect it to your network at home, and actually do your tube setup and get the thing running. And then when you're whitelisted, you can bring it back in and connect it at school.
And it'll remember both.
Yes.
Okay.
Yes.
Yep.
All right.
In fact, once it's whitelisted, it might even automatically connect when you plug it in at school.
Yeah.
Yeah, that would be. And then
Okay.
we should ask Caesar based on the number of units that we have to help us out with that process.
Mm-hmm. You might need some more extension, power extensions.
I think we need some extension cords for some power stations. We have because ours are in this, at least in my classroom, mine are in the center on the floors, and so we have some around the edges. But
Okay.
Extension power and tape.
So are you going to have some naming sessions for all the different teams?
I haven't got that far yet, Tony.
Yeah, you might actually want to do the mission patch lesson and have each team design a mission patch.
Yeah.
Give themselves an identity, and then they could actually create that mission patch to put on the covers. I have our mission patches on them. They could actually design it and decorate their sleeve with their mission patch.
Oh, and then you print them out, or?
No,
yeah, and
the mission patch is each teacher has a mission patch, each teacher kit, and also there are stickers in that one wider box. The one wider box has all the student kits.
there you go.
Yep, exactly.
So Space 23, SpaceX 23, is that Shanna or is that me now?
Well, there should be. Well, that's yours, I guess, now since you put that lab on your name. 61 is on you. So.
Okay. So then these little patches are just for them, for the kids.
For the teachers, yeah, I have mine on my lab coats.
Okay. All right.
So I also get the uphill and downhill rides. Get their flight patches.
Nice. Hey, we can steal a couple welding jackets, Shanna.
There you go.
You can create your own flight jacket. Yep.
Oh, that'd be awesome.
Yeah.
Or get coveralls and make astronaut flight suits.
Anna, I sense a video coming on.
I know, right?
I say that only because I have some. I don't have. They're here handy. I just have my lab coats here, but I have a blue flight suit that I've made up, and I have an orange one, and so it's.
Yeah, we would love to have pictures with all the students with their lab coat on, flight coat.
Lab coats going on purchase order. Miss Rana, can you make that happen?
Bomber jackets.
Oh,
These would look nice on a little white lab coat.
But it is a great, you know, and I said that this is, I really like to have people do this in a multidisciplinary way, because not everybody's like, oh yeah, so what, space. But there is a whole history in terms of the military and space exploration of commemorating missions and accomplishments through these patches. There's a whole, you know, it's an esprit de corps piece. The artwork of it is phenomenal, and I think it's well worth going into, and kids really get inspired by it. And what are their inspirations? What are their influences? What would they want to have reflected in their flight insignia? To even the point where most of these, you know, these people have call signs. All the astronauts who come from the military all have call signs. So like Leland Melvin, he's Flo, and Jack Fisherman is Two Fish because there was already a One Fish. So there's an Iron Mike, and you know, it's just like all kinds of things.
Michael, I want to share one other thing with you.
Mm.
Their school is really close to the Air Force Air Base.
Oh,
that's where the Blue Angels headquarters is.
Oh, so the Blue Angels so you're Navy, so it's a Navy base. So you're down at oh shoot, it just escaped me. I know the name yet. So yeah, so a lot of your students probably already know about this tradition, or maybe you can even get one of the get. I bet send an email to the Blue Angels, and I bet you could get somebody to come out and talk to you about it.
Wow.
I had an opportunity to fly on what was the big gut plane? It was not Fat Albert. It was the Blue Angel. I got an opportunity to fly with them though when
on their support plane.
Yeah.
Wow. Wow. Will you have that opportunity again?
No, I was chosen. Only one community member is chosen each year, and it's for whatever area that they're chosen. So mine was civic engagement in the community and how I give back. So I got selected for that. So I probably will never, and it kind of coincidence, my mom went in her 30s, also got selected to fly with him.
Wow.
Cool.
That would be so
And if you got
cool.
any parents that are military, that, you know, that's a good resource. Have them come in and talk about their service patches. So nice way to bring it all together.
Yeah. That's awesome. Well, any other questions?
I feel this is a good foundation. I think I'm a little bit of a control freak, so I like knowing I opened the box, we did it together, we put it together, we powered it on, we know it just needs Wi-Fi, and so I think Shanna and I and Brittany will be good, and the lessons and how to clone the lessons, where students can start with their notes. So a lot of that, I think we have a lot to start with, and we'll get started by creating our classes. I think that's what we'll do, and adding our students using the little template to form our classes. Our classes change a lot the first 2 weeks of school, and so those probably will be finalized. Is it easy to remove a student and add a student individually?
Yes, you can assign a student at any time, and you can add a student individually as well.
Awesome. Okay, well then we could get set up with our class list our texted class list we have right now, and then change them as the kids fluctuate in and out.
Awesome. Well, welcome aboard. we are very, very happy to be working with you. And Michael got really excited about what you guys are actually working on over there.
Yeah, no, I think this is an ideal connection. I think there's so much that you'll be able to do with it, and we can do with you. Yeah. So El Centro, you are go for grow.
We're ready to put in our barbecue and get our greenhouse back up and going again, and just get back to normal. So you're contributing to the excitement and engagement of the students moving forward. It's something new, and it's something we can get excited about as teachers too. So something new and exciting for us to look forward to. So thank you.
Awesome. All right, have a wonderful weekend. You know how to get a hold of us. So
Yeah, thank you for being so accessible. Thank you. Thank you.
no problem.
Okay.
Bye.
Bye.
Bye.